This video explains how to use FARfield 2 to create flexible overlays and is part of the FARfield Pavement Design series by the Federal Aviation Administration, Office of Airports. Refer to Advisory Circular AC 150/5320-6, Airport Pavement Design and Evaluation, and AC 150/5335-5, Standardized Method of Reporting Pavement Strength, PCR, for the basis of the design and evaluation procedures implemented in FARfield. In this video, we will look at design considerations for flexible overlays, functional versus structural overlay, performing a structural analysis for a flexible overlay of both flexible and rigid pavement. Before you can design a flexible overlay, assess the existing conditions of the pavement structure. For pavements that are still adequate structurally, it may be possible to restore the surface conditions with a functional overlay. A functional overlay generally consists of milling off 2 to 3 inches of the wearing surface and putting back the same amount of new asphalt. This is often referred to as a mill and fill. A functional overlay does not change the structural capacity of the pavement, but will improve the surface friction and restore the wearing surface. A structural overlay may be required if traffic has changed in frequency or composition. Note: a structural overlay will not correct deficiencies in the existing subgrade, subbase, or base layers. Reconstruction is the only way to correct widespread structural deficiencies. See AC 150/5320-6, Chapter 4, for design considerations for rehabilitation. Assess the existing conditions with a combination of visual inspections plus field and laboratory testing. Determine the thickness, condition, and stiffness of each pavement layer. Use field and laboratory tests to establish the condition and strength of the existing materials. If available, review the PCI survey reports. Evaluate the existing surface for roughness, surface friction, drainage, material distress, structural damage. To evaluate roughness and surface conditions, consider the following. Have there been recent pilot complaints or reports of damage to aircraft? Is the roughness condition due to a surface or subsurface issue? Has the surface profile roughness been tested with a profiler? Have there been any pilot complaints about difficulty in braking? Does the pavement have adequate surface friction? Has the surface friction been tested? To evaluate drainage, consider the following. Does the pavement have drainage issues? Are the drainage issues related to longitudinal and transverse surface profile of the pavement, or the sizing and/or location of drainage structures? To evaluate structural damage, consider the following. Is there load-related cracking or rutting, indicating structural deficiency? Is rutting the result of asphalt mix issues such as wrong binder grade, too much binder, tender mix, or other mix-related issues? Is there rutting in the base or subbase? Has there been a change in the composition or frequency of traffic as compared to what the original pavement structural design was based on? If there are no changes in traffic and no structural issues with base or subbase, then this pavement is a good candidate for using a functional overlay to correct surface issues of roughness, friction, or minor damage. It is a good practice to run a FARfield analysis of the existing structure to verify that it is structurally adequate for the traffic. When doing a functional overlay, you must determine how much material to remove, either the entire layer or just a portion of it. When removing a portion, evaluate if the remaining thickness can support the loads of construction equipment and if there is a good bond between lifts. Avoid leaving less than a 2-inch layer of asphalt. If there are any issues with bond between lifts, or if there is only a thin layer remaining, mill through the lift interface. If the evaluation indicates a need for a structural overlay, use FARfield to perform a structural analysis. Let's look at how to do a structural analysis for a flexible overlay on a flexible pavement and a flexible overlay of a rigid pavement. In the first example, we will look at a flexible overlay of a flexible pavement. Let's open an existing job of FARfield video. Now, let's set up the starting pavement structure. In this example, we will start from an existing structure as developed for the section FlexGA. In the Explorer window, right-click section FlexGA. This brings up the option to copy, delete, or paste. Choose Copy, then right-click again and select Paste. This creates a new section called FlexGA Copy. Select this new section and rename it to FlexGA Flex Overlay. Next, edit the structure to add an HMA overlay layer as the top layer. Open the Material window, select P401/P403 HMA Overlay, drag this into the grid view of the pavement structure, then drop it on top of the P401 HMA surface layer. The structure now consists of P401 HMA Overlay, P401 HMA Surface, P209 Crushed Aggregate, P154 Uncrushed Aggregate, Subgrade. When we added the overlay layer, Farfield automatically changed the design layer to the top P401 HMA Overlay layer, as designated with the small red arrow in the grid view. In our example, the traffic at the airport has a new commercial service scheduled of an Embraer 195 standard with 2 daily departures, 5 days a week, 52 weeks a year, growing at 5% per year. To add this traffic, go to the aircraft window. The Embraer 195 is in the regional/commuter group. Edit the annual departures and growth rate to reflect the scheduled activity of 520 departures and a 5% annual growth. Farfield calculates the total departures as annual growth times design life in years divided by 200 plus 1 times annual departures times design life. Next, run the design analysis by clicking the Run button. Since this is a flexible overlay analysis, Farfield adjusts the thickness of the overlay layer to limit the subgrade strain to prevent subgrade failure. Since we selected Calculate HMA CDF, this was also calculated. In this case, the subgrade strain controlled. The recommended overlay to accommodate the traffic is 7 inches. In reviewing the section report, we now see that the new aircraft, the EMB 195, is contributing 100% of the damage to this section. This is as expected since this aircraft is significantly heavier than all the other traffic and also has the highest tire pressure. If you go back and check the FlexGA design, the truck axle, representing a maintenance vehicle, was the controlling traffic. Farfield will not let you analyze less than 4 inches of existing P401. So, if you need to mill off some of the existing P401 prior to adding the overlay, you cannot model this in Farfield. Since Farfield will not let you make this change, any adjustments in overlay thickness due to milling would be discussed in the engineer's report. In this example, if you mill off 1 inch of the existing P401, add 1 inch to the overlay thickness to get your construction thickness of 8 inches. Analyses of flexible overlays of rigid pavement are similar. However, you must understand how the rigid pavement is performing. Is it still functioning as a rigid pavement, or like a really good base? If you model the existing pavement as a rigid pavement, Farfield assumes it is still supporting the load through flexural action. Use engineering judgment when evaluating flexible overlays of rigid pavement. The condition of the existing rigid pavement prior to an overlay is expressed by the Structural Condition Index, SCI. The SCI consists of the load-related distresses of the Pavement Condition Index, PCI. The SCI is reported on a scale of 0 through 100. A pavement with no visible distress would have an SCI of 100, and a pavement with complete structural failure would have an SCI of 0. An SCI of 80 is the FAA's definition of structural failure of a rigid pavement, and is consistent with 50% of the panels in the traffic area having a structural crack. Pavements with an SCI below 80 are generally not candidates for a flexible overlay. Start with FlexGA rigid pavement structure, which consists of 6.5 inches P501 surface, 6 inches of P209 base on a subgrade, with a modulus of 4,500 psi. First, we will enter new traffic of 520 annual departures of the EMB 195 with a 5% annual growth rate. Next, add a P41 HMA overlay layer to the top of the pavement. To do this, drag the P41 HMA overlay layer from the material frame or add a layer in the layer property frame. As soon as the HMA overlay layer is added, the pavement type changes to HMA on rigid, and boxes appear beneath the grid view for SCI and %CDFU. The cumulative damage factor used, or CDFU, represents the structural damage prior to the first crack. A review of the last pavement condition survey indicates that the pavement has an SCI of 95. That is entered in the box below the grid view. For flexible overlays on rigid pavements, Farfield assumes the existing rigid pavement supports through flexural action. When the overlay thickness exceeds the thickness of the rigid pavement, it may be more economical to consider the existing concrete as a high-quality base. If after activating design options from the Explore panel, you set Allow Flexible Computation for Thick Overlays on PCC to Yes, Farfield will treat the rigid pavement as a rigid high-quality base and report the thinner flexible overlay. The overlay will be the same thickness as the PCC. With the Allow Flexible Computation for Thick Overlays set to No, you can see the impact of this by running the analysis again. This results in a recommendation of an overlay thickness of 10.6 inches, which is 4.1 inches more. Setting the design option for Allow Flexible Computation for Thick Overlays on PCC to Yes results in a recommendation of a 6.5-inch overlay. Once the analysis is complete, a review of the section report indicates the minimum HMA thickness was reached. In this example, we copied an existing section, added an overlay layer, added additional vehicles to the traffic, and ran our thickness analysis for the flexible overlay of flexible and rigid pavements. In the overlay of rigid pavement, we considered the SEI of the pavement and evaluated the overlay thickness considering the rigid pavement as rigid and as a high-quality base. Remember to evaluate the existing condition of a pavement to determine if an overlay is an option, or if the pavement should be reconstructed. Regardless of the starting pavement surface type, all Farfield overlay designs involve the same basic steps. Create a starting pavement structure. When possible, copy the existing structure and add an overlay layer. Adjust material properties to match field conditions. Create or modify a traffic pattern. Run the thickness analysis. Check HMA CDF. Save the section report for the engineer's report. These reference materials provide further guidance on designing, evaluating, and constructing airport pavements. Please visit www.faa.gov/airports to find these documents, this tool, and other related design tools. For additional information, contact the FAA's Office of Airports. The FAA appreciates your interest. Safe landing.